In this section, we will look at exploratory data analysis. We'll be focusing on visualizing the data values in our variables. So we'll begin with a histogram. So what is a histogram? In simple terms, it is a visualization representation of the distribution of a quantitative variable. The appearance is similar to a vertical bar graph, but it's mainly used for continuous distribution. The key phrase quantitative differentiates the histogram from its cousin, the bar graph, which is more useful in representing a nominal variable. To be more precise, we should say that it approximates the distribution of the variable being studied, because the bin value is often chosen arbitrarily. If the data is not discretized correctly, the representation it produces may be misleading, or alternatively, the underlying distribution may in fact be different from the one conveyed by the histogram. So more specifically, a histogram is a visual representation that gives a discretized display of value counts. So based on my definition, it may seem that I am discouraging the use of histogram, but for practical purposes, it is a useful technique, and in actual practice, it is a very common tool and a good starting point to analyze variable distribution. But it is important to keep this definition in mind, in the back of your mind, to avoid certain pitfalls when exploring variables. In practice, you will use histograms for this reason, but you should always have this definition in the back of your mind. Now that we have discussed what a histogram is and why it is used, let's now move on to a practical example that we will conduct in Python. So there will be a couple of files in the downloadable resources. You will see this histogram IPython notebook and as well as the Excel file. And we'll discuss shortly what the Excel file is all about. But we'll go ahead and start with developing a histogram. So the first thing I'm going to do is run pylab inline in the very first cell. And I'm going to import pandas, and I'm going to also import series from pandas. Then we're just going to create a NumPy seed of 23 so that we get consistent result. And I'm going to create a sample object, and in this I'm going to create 100 randomly generated values from the normal distribution. So I'm going to use the ravel method at the ends because I want to flatten the one-dimensional array, right? Let me go ahead and execute this cell, and you will see the first 5 values in the sample object. Populating the interactive namespace, so that means that pylab inline has executed and it has imported NumPy and matplotlib, right? And now these are the first 5 rows we have generated. Okay, let's now move on to the next cell. I'm going to generate a figure object. Now we're going to plot the histogram based on this data set that we generated. So I'm just going to create the figure object, and the axis I'm going to give it the histogram method and pass the dataset sample and color, give it a color value and alpha value. Finally, I'm going to set the variable value and the count as the labels for X and Y. So let's go ahead and execute this. So this looks to be a normal distribution if we superimpose a continuous function on top of this. However, if you want to do this a very simple way and you don't care about the presentation, we can just simply call the hist method on the sample series object. So let's go ahead and execute that, and we get the exact same histogram. So recall that the wildcard helper function that I discussed in an earlier video named Jupyter Basics. Well, the reason I have mentioned that helper function is because I wanted to reiterate that importance of the helper function and the power of IPython. Dealing with many different types of software on any given day, I cannot remember all of the methods and functions, but I always know the right place to find that information, right? So my personal recommendation is that you do not rely on Google for simple things, but rather you should learn to rely on the official documentation and the IPython facilities, such as the helper function. So by helper functions, I mean things like the magic functions, the question mark, the wildcards, and things of that nature that we covered in the basics video. The reason why I have brought this up is that you may get a quick answer from Google, but it may take longer, and more importantly, it is unlikely that the answer will contain technical information for you to comprehend the workings of the solution, at least not as a beginner. Conversely, there are times when the documentation does not provide enough details, and in that case, by all means, go ahead and use Google for your solution. So I'm going to demonstrate the wildcard method that I used because I couldn't remember what the method was to label the X and Y axis. But I knew it had contained the word label. So I'm going to go ahead and execute that. So it brings up a bunch of methods here on the axis object that we created earlier. And if you go look down over here, I see, well, this contains X label. Right, then I recall that, oh yes, that's the correct method. And similarly with the Y label, that is the correct method to label the Y-axis. So we had counts and variable values. Okay, so now you may be wondering, well, in this example, we basically generated values using the random function, but what if I have an Excel file that I want to import and analyze the variables, and I want to look at the distribution of those variables, right? So your Excel file may look like this, which has a lot of columns, and then it has all these values associated with these columns. How do we go about and visualize this Excel file? This is the reason why I included the Excel file with this IPython notebook. So we're going to use the import function here. We're going to import the Excel file, and we're going to import the contents into the data frame object. So I begin with the sales.xlsx. So that is the file name. And then I'm going to say index column 0. And I'm going to parse only columns from 4 to 12. The number of rows that I'm going to skip is 3. And I will show you the reason is because my Excel file, the contents of the file does not start until the 5th column, right? So I want to skip these 4 columns here, and I'm going to skip the first 3 rows because it doesn't contain useful data, right? My columns begin from the 4th row here. So I'm going to skip the first 3 rows, and I'm going to only import data from the beginning of the 5th, right, which is the ending of the 4th, and all the way to the 12th column, right? So let's go ahead and execute that cell. And there we go. This is what our data frame looks like, and that's exactly what we want to import. So let's go ahead and generate a histogram for the population column. So I'm simply going to type in the name of the column and call the histogram method hist. So there we have it. This is the histogram for the population column. We can see that the distribution is skewed to the right, and most of the values appear to fall approximately between 4 to 12 million, which is in millions, right? So with that, we'll conclude the discussion on histogram.